Welcome back again. For the next experiment, we have determination of refractive index of a liquid by using a simple convex lens and a plane mirror. So how are we going to determine the refractive index of any liquid? Of course, we are going to use the concept of combination of lenses. But before we proceed to the theory, let us see what are the apparatus required for the experiment. We need a convex lens, we need a plane mirror, we need that transparent liquid whose refractive index is to be calculated or determined. Then we need an optical needle, the kind of thing that you have already seen in an optical bench, which acts like an object. And then we need a stand with a base to hold on the needle. Then we need a plumb line, a scale is also good enough. We also need a sperometer. The sperometer will be required to determine the curvature, the radius of curvature of the lens. This is a particular experiment that we usually do in class 11. And then of course a scale. So let us understand how we can determine the refractive index of a liquid by using a simple convex lens and a plane. So what we can do is that let us assume that there is a plane mirror. Okay. You can actually find out the rough focal length of the convex lens. You know how to do it. You can hold the lens and you can make light fall through the lens, and you can stand and for the picture, focus the picture on a particular wall and get an idea about the rough focal length. Once you know that, you get an idea that what will be the focal length of the lens, but that's not the actual way to determine the refractive index of the lens exactly. So what we do is, we take the plane mirror and we place the lens. So if I have an optical needle, so I try to adjust the optical needle in such a way that its image coincides. Now how is this possible? This is only possible if the object is placed at the focus. So how do I ensure that if the object will be placed at the focus? I need parallel lines, and that is exactly what a plane mirror will do. Plane mirror will be like the source of parallel lines from which you can imagine parallel lines going in. So this distance gives you an idea of the focal length of the lens, which I will call as f1. So f1 is the focal length of the convex lens. That is how I determine using the optical needle, plane mirror and the lens. All I need to do is ensure that the image of the object coincide. Now to determine the refractive index of the liquid, what I do is I take away the lens and I will now put some liquid, the liquid whose refractive index is to be calculated. So I take out the lens and I will now put some liquid and again place the lens back. Now here you have to observe that when I place the lens back, there will be a layer of liquid that will be trapped under the lens and in between the mirror. So this is the liquid whose refractive index is to be obtained. And now I can imagine this to be a combination of two lenses. What are the two lenses? Of course, this is lens 1 and this is a plano-concave lens that has been formed because of the liquid trap. So this lens has focal length f1 and this lens suppose has a focal length f2. So the combined focal length I know is given by 1 by f plus 1 by f1 plus 1 by f2. So now I repeat the same experiment. I place an optical needle and then I determine the combined focal length. Assuming that this distance is my combined focal length. But this are like two lenses in combination with each other. One is the convex lens and other is the plano-concave lens. And the formula for the equivalent focal length is simply 1 by f, which is the equivalent focal length, is equal to the sum of 1 by f1 and 1 by f2. Agree? Now the purpose is to determine f2. So 1 by f2 can be found out to be equal to 1 by f minus 1 by f1. Agree? Now all of us know about the lens maker's formula. If you remember lens maker's formula, it says that 1 by focal length is given by n minus 1 into 1 by r1 minus 1 by r2. So if I take this particular plano-concave lens, suppose this side has a radius of curvature r1 and this side has radius of curvature r2, which is of course infinity, because this side's plane and there is no curvature. Only I should consider this curvature, but this curvature is same as the radius of curvature of the lens, which can be determined by using what? The sperometer. So r2 is equal to infinity and r1 is equal to r for the plano-concave lens. So 1 by f2 can now be written as n minus 1 into 1 by r, or I can write f2 is r divided by n minus 1, or n can now be determined as 1 plus r by. So this is the required theory for determining the refractive index of the material of the liquid that is trapped between the lens and the plane mirror. So you have to be careful that you should measure the radius of curvature of the convex lens by using a sperometer. Of course, this is a technique that you are taught in class 11 practicals. Of course, ma'am will be demonstrating how to do that. So that's all about the theory of the experiment. Now I will request ma'am to demonstrate how to determine the refractive index of the liquid. Thank you.
Now we are going to find the refractive index of liquid. Here, liquid we are taking we are using water. So we are finding the refractive index of water using plane mirror and convex lens. Now please, the middle is fixed, optical middle is fixed on the transfer, and the convex lens was placed on the plane mirror. We will take rough focal length as we have done earlier in case of optical lenses. We have focused a distant object on the wall and we have measured rough focal length. Here also we can do the same thing to have an idea about the approximate focal length of the lens. Now, lens was kept in the mirror. When we bring it closer, as it is better if bring it closer so that you can locate the virtual Elliott image of this optical needle. Once you check the virtual Elliott image of the needle, then gradually it is raised and it is adjusted in such a position so that the tip of this needle coincides with the image tip of the needle. Here you can see the real inverted image on the lens surface. Seeing that, we have to adjust, move the needle upward and downward and focus it at such a position so that the needle coincides with the real inverted image of it. Then now we will measure the now this position is the focal length of the convex lens. But when the object is arc focused, the rays passing through focus strikes the lens and emerges parallel. Parallelly strike the plane mirror, gets reflected back around the center, strike the lens again, and after reflection through the lens converges to focus again. So here, as the path is being retraced after reflection and reflection from the mirror, this position is focus. So what will you do? You may use a plumb line, or simply you can use a scale to measure and keep the scale vertically above the lens to measure the distance of the needle tip from the lens. Now it comes around 11.3 centimeters. So we measure the distance of the lens from the needle tip. Note down here. There is a format here. Arrangement of lens without liquid mix. On the mirror, glass lens was kept. Then distance of the needle tip from lens surface 11.3 centimeters. Suppose it was mentioned here. Then distance of the needle tip from plane mirror. Remove the lens. Measure the distance of the needle tip keeping this vertically above the mirror. Measure the distance. It may come around 12.1 centimeters. 12.1 centimeters. Find the average of both these, that is mean length, and that is equivalent to focal length of the lens. Once it is done, this can be taken and try to adjust similarly so that the needle coincides with its image. Again, using a scale, measure the distance of the needle from lens, from mirror, and the average. Likewise, 3 times you note the observation, find the focal length of the lens of the needle. After that, pour little water, few drops of water is poured on the mirror and the glass lens was kept. What happens? The layer of water which is in contact with the plane mirror, the lower surface of water is plane, and as it is in contact with the convex lens, by convex lens, the water surface adheres to the convex lens and becomes a concave surface. So the liquid or the water comes a plano-concave liquid lens. Now it acts like a combination of plano-concave liquid lens and a glass lens. Then you have to follow the same process, vary the position of the needle and fix it at a position so that again the needle tip coincides with its image. Measure the distance of the needle tip from lens. Note down in the observation table here with liquid here. Then remove the lens. Measure the distance of the needle tip. Definitely not from water, definitely from mirror surface. Note down here. Then find the average. That gives you focal length of the combination. So repeat this thing again 3 times to reduce error. So you found focal length of the combination and focal length of the lens. And using the formula, as the lenses are combined together, the power of the lens gets added. 1 by f is equal to 1 by f1 plus 1 by f2 as it is written here. You got the focal length of the combination, that is capital F. You got focal length of the lens only, that is f1, from which you can find 1 by f2, that is inverse of the power of the water lens only. Once we got 1 by f2, we will apply Lens-Makers formula to find the reflected index of water. After being solved, we are finding A is equal to 1 plus R by f2. Already we have found 1 by f2. Here, from this equation, we have found 1 by f2 already. Only our aim is to find radius of curvature, and that to be found using spherometer. Spherometer is already done in class 11. Just to remind you, let me tell you, here there is a main scale, and on the main scale, 1 centimeter is divided to 10 subdivisions. So 1 division is equal to 0.1 centimeter. There are 100 divisions on the circular scale, and when you rotate once, it covers 1 division along the main scale. So pitch of the screw guys equivalent to the linear distance covered due to one complete rotation of the circular scale. That means 0.1 centimeter. Each of this parameter is 0.1 centimeter. Now least count of this parameter is pitch divided by number of divisions on the circular scale. So pitch 0.1 centimeter divided by 100. That is 0.001 centimeter is the least count of the spirometer. Now using spirometer, radius of curvature R is equal to L square by 6h plus h by 2. R is equal to L square by 6h plus h by 2. This is the working formula for radius of curvature using spirometer. And what is L? L is the average distance between the legs of these are the 3 legs of this spirometer. 3 legs. Average distance between the legs of this spirometer is L. For that, we have to take the pinpricks. We place the legs on the paper, on the plain paper. Just press it. Mark the 3 positions. The pins are pricked on the paper. So we will mark these 3 points. Encircle those 3 points. Join these 3 points with the help of scale. This distance let it be L1, this let L2, this may be L3. And find the average. That average, here it is also written L, average distance between the legs of this parameter is L, L1 plus L2 plus L3 divided by 3. We got L. Now we have to find only H, that is the sagitta. H is the sagitta we have to find using this observation table so that we can calculate our radius of curvature and that have to be substituted there in the formula to find different radius. And to find sagitta H, we have to take ICSR, initial circular scale reading, number of rotations, FCSR, process almost similar to that of scissors. Keep the lens, raise the central tube little upward and keep it on the convex surface and place it tightly so that the 3 legs are in contact with the convex surface. Place it tightly, then rotate the disc so that the point comes when the disc stops moving. That means the central screw touches the legs. At that point, the division, circular scale division, which is coinciding with the linear scale, that is ICSR, to be mentioned here. Then, remove the lens, keep it on a flat surface, plain surface may be on the top of a plane mirror. Then, rotate the disc again. Suppose it was coinciding at 35. Then, while rotating, you will count number of rotations. 35 to 35 one rotation. Next, it stops. So number of complete rotation 1 to be mentioned here. Then FCSR. Finally, when it stops moving, the circular scale division which is coinciding is suppose now 83. So FCSR is 83. Number of rotations 1. ICSR I think that will be 35. FCSR 83. Then we will find additional circle. After one rotation, second rotation was not complete. Out of 100 divisions, 2 divisions move ahead. So that additional divisions, to find out that extra divisions, use the formula that is I minus F if I greater than F, or 100 plus I minus F if I less than F. In our case, for this case, now we find that I is less than F. So you will find difference of the extra division mode is equal to 100 plus I minus F. Find the difference. Then X, that is the sagitta, is equal to number of rotations into pitch. Number of rotations we found here 1 into pitch 0.1 centimeter plus extra divisions, additional circular scale divisions formed as we found using this formula. Extra divisions into least count, that is 0.001 centimeter. So like this you got the sagitta. This is a revision of class 11 experiment. So I hope all of you understand. Done. This 4 times at least to reduce the error. And find 4 times x, then find the mean x, put the values mean L and mean h in the formula. R is equal to x square by 6x plus x by 2. Put the value of L and h and radius of curvature R. Once you find radius of curvature R, you here 1 by f2 you will get a negative value. When we do the experiment, we will find 1 by f2 is negative. As it is the plano convex lens, plano concave lens, f2 is negative and radius of curvature also will be negative. So negative will cancel and it will be positive. As refractive index of water is around 1.33, we expect our result also will be very close to 1.33 if it is not exactly so. So we expect R by F2 will be around 0.33 or very close to 0.33, so that refractive index will be around 1.33. May vary from 1.27 to 1.35 and also it is correct. So basically the precautions is to avoid parallax. And 7 should be handled properly. Then we will get a correct.